So our next question is 2.54. The question is, if the photon of wavelength 150 picometer strikes an atom and one of its inner bound electron is ejected out with a velocity of 1.5 10 to the power 7 meter per second, calculate the energy with which it is bound to the nucleus. So here you need to find out is threshold energy. Okay, so that means to say the energy which is ejecting out, that one's energy is what you're supposed to calculate. So let's write down what is given to us. We are given with wavelength in terms of picometer. So we can write over here lambda is equal to 150 picometer. But velocity is in terms of meter per second. So you have to convert picometer to meter. So for this, your 1 picometer is 10 to the power minus 12 meters. That is a conversion from picometer to meter. Now, to show the relation between lambda and the energy related to this wavelength, that is your energy of the incident photon, you will have E, or energy of incident radiation, where E is equal to hc by lambda. H is Planck's constant, c is velocity of light, lambda is the wavelength given here. Let's substitute the values. So this is 6.626 into 10 to the power minus 34 joule second into velocity of light, which is 3 into 10 to the power 8 meter per second, divided by lambda value is this, so 150 into 10 to the power minus 12 meter. Meter and meter will get cancelled, seconds inverse and seconds will get cancelled. When we solve 6.626 into 3 divided by 150, you will get 0.1325 into 10 to the power minus 12. When it goes up, it will become plus 12. So minus 34 plus 8 plus 12 will give minus 14 joule. Shift your decimal to the right and this will become 1.325 into 10 to the power minus 15 joule. This is going to be the energy of the incident radiation. Now we need to see what is the kinetic energy of the ejected electron whose velocity is this much. So for that we have to find out what is the kinetic energy. So kinetic energy of the ejected electron equals 1 by 2 mv square. M here, because you're taking electron, m is going to be mass of electron, which is a standard value. So let's substitute the values. So in this case, kinetic energy is equal to 1 by 2 into m is mass of electron, so that is 9.110 to the power minus 31 kg, into velocity is given to us in the question, so that is 1.510 to the power 7 meter per second square, because it is squared here. Now when you square this up, multiply with 9.1, you will get 20.475 10 to the power minus 17. How did I get minus 17 here? 7 into 2, 34, which is 34 here. Now this 34 with 31 will give you 17. Okay, so once you finish that, you have to divide it by 2. Once this is done, kg will be as it is, meter will become meter square, seconds inverse will become seconds to the power minus 2. Divide both of this and you will get 10.237 into 10 to the power minus 17 kg meter square seconds minus 2. Now this one, kg meter square second minus 2 is nothing but 1 joule. So you can write here 10.237 into 10 to the power minus 17 joule. Why did I change this to joule? Because the other energy is in terms of joules. Now, they are asking us to calculate the energy with which it is bound, which means threshold energy. That is what we're supposed to calculate. So, we know a equation which can relate energy of incident radiation, kinetic energy of the electron and the threshold energy. There is one equation that we know. What is that equation? So, you can write here energy of incident radiation equals threshold energy plus kinetic energy. This is the equation. So in this, we know the kinetic energy, that's what we calculated. We know the energy of the incident radiation. We should know what is threshold energy. Easy one, we just have to substitute the values. So we can write threshold energy equals energy of incident radiation, that is 1.325 10 to the power minus 15 joule minus kinetic energy, which is 10.237 into 10 to the power minus 17 joule. Subtract both of this and you will get, this is equal to, in this case both of their powers are different, right? Since both their powers are different, we are going to make it same. So what we will do here is, in this case, either you convert both of them to 16, 10 to the power minus 16, so that becomes easier for us to write. In that case, here you will have, this is going to be 13.2 into 10 to the power minus 16 joule minus this, when you convert it to 16, this will be 1.023 into 10 to the power minus 16 joule. In addition and subtraction, the powers have to be same. That's why we do this entire simplification. Now, when you simplify both of this, it will come to 12.176 into 10 to the power minus 16 joule. This is going to be the threshold energy required for this question.